This question concerns the equation we see here, in which we want to find out integer solutions. The first part wants to show that this expression is equivalent to this expression for some values of a and b. Now we could start factorizing the first line, but it is far easier to expand the brackets in the second and compare like terms. Comparing these lines term by term, we can see uv is uv, plus 3u is plus bu, minus 3v is minus av, minus 18 is equivalent to that if a and b equals 3. And we can see that when we have those values, these two lines are indeed equivalent. We now wish to seek integer solutions to this equation. If u and v are integers, then so are u minus 3 and v plus 3. So we're looking for two integers that multiply together to get 9. If we draw up a table with possible values, first pair that springs to mind might be 3 times 3. Another pair, 1 times 9. And then 9 times 1, but there are 3 remaining, because remember, we could have a negative times a negative getting a positive value. And for each of these values, we can work out the corresponding values of u and v. And those are the 6 solutions to our equation. In the final part, we're given this new-looking equation. Now we could start solving from scratch, but we've been given all those clues from the previous part. So see if there are any parallels between the two equations presented to us here. Now the first thing that jumps out is, well, the minus 18 appear in both equations, and somehow we've got to make these terms match up. That expression may look familiar. The difference of two squares formula see if we can match one of these with u and one of these with v. We don't know yet which way round. But looking at this term, we can see a good choice would be because if we take away one from the other, we get u minus v is 2y. And then we have 6y would be 3u minus 3v. And this substitution shows that these two equations are now equivalent. We can now write x in terms of u and v. And we need to check x and y are still integers. I've kept our values from u and v from before, so let's see. And we can see that each of the pairs of solutions yields another pair of integer solutions. So we will have 6 pairs of integer solutions to this equation.